Hello students, welcome to lecture 10 of online chemistry classes. In last class we learned about the mole concept and I have given you some questions. In fact, one homework question I have given. 3 questions we solved together in the last class. The one question which I have given was from the 200 milligram of carbon dioxide, 10 raised to 24 molecules are removed. How many moles of CO2 are left out? So there is one sample of 200 milligram of carbon dioxide, and from that 221 molecules are taken out, and they are asking how many moles of CO2 are left out. We know the formula: number of moles is equal to number of molecules by Avogadro number, and number of moles also equals to mass of substance, here in this case molecule CO2, divided by gram molecular mass. As both these formulas are related to number of moles, you can write number of molecules by Avogadro number is equal to mass of molecule divided by gram molecular mass. We calculate the mass of 10 raised to 21 molecules. So W is equal to N by Na into gram molecular mass. This N is number of molecules, which is 10 raised to 21. They have been removed out. So we are calculating the mass of molecules which are removed out. So N is 10 raised to 21. Avogadro number is 6.02 into 10 raised to 23. Gram molecular mass of carbon dioxide is 44, because one carbon is 12 and 2 oxygens are there. 16 plus 16, 12 plus 16 plus 16 is nothing but 44. If we simplify these numbers, what we get is 0.073 gram. You can use simple calculator and you will get this number. So this is the mass of carbon dioxide removed out. Initially we started with 200 milligram. We converted that to gram, 0.2 gram, and from that 0.073 is removed out. So left is 0.127 gram. But they are not asked how much of CO2 in mass, in terms of mass left, but they are asked number of moles. So you can use number of moles is equal to mass divided by gram molecular mass, and you get 2.88 into 10 raised to minus 3 mole. So very simple question. I hope that you already solved this question and you might have got this answer. If you are not getting this answer, write this solution which I have written and you can solve it once again, because after solving more and more questions, only will understand what exactly the way to crack this type of questions. So we'll go ahead, see the question number 5 now. Many more questions today we have to solve. So it is question number 5, and the question is, how many electrons are present? How many electrons are present in 1.6 gram of methane. We know that methane is the simplest hydrocarbon. Alkane it is CH4. So to calculate how many electrons are present into 1.6 gram of methane, we should know how many molecules are present in 1.6 gram of methane. We have this formula: number of molecules is equal to number of moles multiplied by Avogadro number, and then again we have to multiply, because this will give us the number of molecules. But one molecule of methane contains how many electrons? So we'll multiply it by number number of electrons present in one molecule of methane. Try to understand this formula. This part already we know. Number of molecules is equal to number of moles into Avogadro number. We have multiplied with this number of electrons present in one molecule of methane, because these are the number of molecules. And if we multiply with this number of electrons present in one molecule, we will get the number of electrons present into it. So this we can now change as number of electrons is equal to, because we have multiplied with this, that's why we have changed this term. Number of electrons is equal to number of moles into Avogadro number into number of electrons present in one molecule of methane. So what is this number of moles? This is nothing but mass by gram molecule mass, because mass is given. That's why we can use this formula. This is Avogadro number. And how many electrons are present in one molecule of methane? One molecule of methane contains one carbon and 4 hydrogen. Number of electrons is nothing but atomic number. Atomic number of carbon is 6. Hydrogen atomic number is 1, 1, 1, 1. So there are 10 electrons present in one molecule of methane. Isn't it? 6 from carbon and 1 each from 4 hydrogen atoms. So it is 1.6 gram molecular mass is 16, because atomic mass of carbon is 12 and these 4 hydrogens together is 4. So this is the 16 gram per mole is the gram molecular mass of 16 gram if we consider it as gram molecular mass. 6.02 into 10 raised to 23, we can write 6.022 also, that doesn't matter. Multiply by 10. 16 is 10 times of 1.6. This 10 and this 10 we can cancel. And we can say 6.02 into 10 raised to 23 electrons is our answer. So 1.6 gram of methane, which is 1 by 10 mole, 0.1 mole, contains Avogadro number of electrons into it. So this is how many electrons are present. It can be asked in any substance. Look at the methodology which we are using. If you understand that, then you can solve similar type of questions if they appear in the exam. But this type of questions are more frequently asked in the entrance examinations. So these questions are very important questions. See the next one. Calculate the number of moles. Calculate. This is the question number 6 now in this series. Calculate the number of moles. Calculate the number of moles in 25 gram of calcium carbonate CaCO3 and number of oxygen atoms. We have to calculate number of oxygen atoms also in that. So you can first calculate number of moles. Mass of calcium carbonate divided by gram molecular mass. 25 gram is given in the question. Molecular mass of calcium carbonate is calcium is 40, carbon is 12, and there are 3 oxygens. 88. So it is 100 gram. So that's why it is 0.25 mole. So we have answered first part of question. Calculate number of moles in 25 gram of calcium carbonate is 0.25 mole. We have asked the number of oxygen atoms into that. So N equals to number of oxygen atoms is equal to number of moles which already we have calculated multiplied by Avogadro number. This will give us the number of molecules of calcium carbonate in 0.25 mole. And as one molecule contains 3 oxygen atoms, we have to multiply it by 3, but before we write number of oxygen atoms in one molecule of calcium carbonate. So this number of moles we have written 0.25. Avogadro number is 6.02 into 10 raised to 23. And number of oxygen atoms in one molecule of calcium carbonate is 3. Because calcium carbonate contains 1 atom of carbon, 1 atom of calcium, and 3 atoms of oxygen. So when you multiply this 0.25 into 6.02 into 10 raised to 23 multiplied by 3, it happens to be 4.515. 4.515 multiplied by 10 raised to 23. So these many oxygen atoms are present in a given sample of calcium carbonate. Yes, you can just write it down, understand, write only equation and try to solve once again. Because again and again if you solve without looking into solution, then only you will understand how I am solving these questions. Calculation I am not doing it for you because simple calculations, if you are not getting this, you can do it 2 times and verify it. Calculation part is not important. How we are writing formula and how are you using it, how we are using it, that is important. Next one, 6 grams of carbon. 6 grams of carbon was completely burnt in oxygen. Was completely burnt in oxygen. What would be the volume of carbon dioxide produced at NTP? Carbon dioxide produced at NTP means normal temperature pressure. How many molecules and how many molecules? Once we know number of molecules can be calculated. How many molecules of the gas will be present? Will be present. So carbon is burnt in oxygen. 6 grams of carbon is burnt. How much of the carbon dioxide will be produced? C plus O2 gives CO2. It means 1 mole, because nothing is written 1 mole here. 1 mole and 1 mole. 1 mole of carbon, 1 mole of oxygen, 1 mole of carbon dioxide is produced. 1 mole means 12 grams of carbon is burnt, carbon dioxide 1 mole means 44 gram because there is molar mass, and volume wise it is 22.4 liter at NT, because that is what we call it as gram molar volume. But we have not taken 12 gram in the question. The question 6 gram are taken. It is half of that, half more. What will be the volume of CO2 produced? It is also half of that, 11.2 liter. We have divided this by 2. This 22.4 liter also divided by 2. Made half of it, which is 11.2 liter. Of course, at NGP only. So, what would be the volume? We said 11.2 liters. How many molecules? So number of molecules is equal to, we can write number of moles into Avogadro number. Number of molecules can be written as mass by molecular mass. Mass is 22 gram here because 44 gram corresponds to 22.4 liter. 11.2 liters corresponds to half of this, 22 gram. We can take that. Or in terms of volume, this number of moles is equal to volume of gas in liter divided by 22.4 liter multiplied by this Avogadro number. So it is 11.2, 22.4, 6.02 into 10 raised to 23. It is 2. It is 3.01. So we can say 3.01 into 10 raised to 23 molecules. Let's see how we solve this question. First we have written the equation C plus O2 gives CO2. If 12 gram carbon, 44 gram of CO2 or 22.4 liter of CO2. 6 gram carbon, 11.2 liter. That is volume. But just along with volume, number of molecules also. Number of molecules is equal to number of moles into Avogadro number. 11.2 by 22.4 into Avogadro. These are the number of molecules. So this is question number 7. If you think that speed is more, you can just pause this video, complete your task, and then you go ahead. Right. Next one. How many years? This is the question number 8 now. How many years would it take to spend 1 Avogadro's number of rupees? 1 Avogadro's number of rupees at a rate of 10 lakh rupees in 1 second. If you are spending 10 lakh rupees, 1 million in per second, how many years it would take to spend Avogadro number means 6.02 into 10 raised to 23 rupees. So you can start with this information. Number of rupees spent in 1 second is equal to 1 lakh means 10 lakh means 10 raised to 6, isn't it? Because lakh means 5 zeros. That 1 plus 5, 6 zeros. So 10 raised to 6. Number of rupees spent in 1 year. If we are spending that much in second, so this is in second, multiplied by 60, it becomes minute, because 1 minute has 60 seconds. Multiplied by 60, that becomes in 1 hour, because 1 hour consists of 60 minutes. Multiplied by 24, because 1 day consists of 24 hours. Multiplied by 365, because 365 days are there in 1 year. So number of rupees spent in 1 year, 10 raised to 6 into 60 in minute, 10 raised to 6 into 60 into 60 in hours, 10 raised to 6 into 60 into 60 into 24 in days, 10 raised to 6 into 60 into 60 into 24 into 365 in a year. Now they asked the Avogadro's number of rupees. Avogadro's number of rupees spent in we'll see how many years afterwards. So we have to divide Avogadro number with the money spent in year. Yes, do this calculation. 6.02 into 10 raised to 23 divided by 10 raised to 6 into 60 into 60 into 24 into 365, and what we get is 19.089 by 10 raised to 9 years. So this many years are required for spending Avogadro number of rupees, because Avogadro number is so large. Look at the number of years we got, 10 raised to 9 years, very large number. So this gives us idea how large number is Avogadro number. So this is about the number of years required to spend the Avogadro number of rupees if we spend 10 lakh rupees per second. The question was about that. I hope you are understanding these questions. Even though first time if you do not understand, I have told you, you should be very patient with these questions. Solve 2-3 times and then you will have understanding. Because once you have understanding, the MCQs will be very easy for you. Question number 9. Chlorophyll the green colored measure of plant pigment is. Contains 2.68% of magnesium by mass. Calculate the number of magnesium atoms. Calculate the number of magnesium atoms in three gram of chlorophyll. This is the question before us. Now we should first calculate number of magnesium atoms they have asked. So first we should calculate the mass of magnesium in chlorophyll. We can calculate that. Mass of magnesium in chlorophyll is equal to 2.68%, means 2.68 gram out of 100 gram, and we have 3 gram of chlorophyll into it, so it is 0.08 gram. So mass of magnesium in chlorophyll is 0.08 gram. This they are given in question, 2.68%, and 3 gram is the chlorophyll. So it is just like 100 gram contains 2.68. This is chlorophyll, and this is magnesium. 3 gram contains how much? So it is 3 into 2.68 divided by 100. Now they ask number of atoms of magnesium into it. Number of moles into iodine. Number of moles is equal to mass by gram atomic mass, because magnesium atoms are present. The mass is 0.008. Gram atomic mass of magnesium is 24.3. I told you, no need to remember all these atomic masses and molecular masses. If they are not asked you to calculate that, they will give in the question in the bracket. I am not writing in your question. The data will be given in MCQs also. In bracket they will give atomic masses. Avogadro number is 6.02 into 10 raised to 23. Yes, simplify these numbers. 1.98 into 10 raised to 21 atoms is the answer which we are getting here. 1.98 into 10 raised to 21 atoms is the answer. Right, so this is question number 9. We'll take 2 two more, and then I will give you some homework. So question number 10 now is, or I will give this question as homework because it's a simple question. I think we can do that. What is the molar mass of a gas if 1 liter of gas weighs 1.5 gram at 273 K and 1 atmospheric pressure, means NTP. This condition is normal temperature and pressure condition, right? So simple question it is. It is expected that we should solve this question. This also will be homework because similar question we have solved. How many atoms of oxygen are present in 300 gram of calcium carbonate? Similar question. We have solved this. And one more. Find out volume of following at STP, also called as NTP. 14 gram nitrogen, 6.02 into 10 raised to 22 molecules of ammonia and C 0.1 mole of sulfur dioxide. Sulfur dioxide is SO2. Ammonia is NH3. I want to give one more question as a homework because it is better if solve question yourself, isn't it? I will give you answer in next class, but you try to solve these 4 questions. Calculate number of atoms of each type in 3.42 gram of sucrose. Sucrose is C12H22 OA. Each type is how many atoms of carbon, how many atoms of hydrogen, and how many atoms of oxygen are present. So these 9 questions we solve together. 4 questions I have given you homework. This is simple question. This is exactly the number has been changed. Same question we have solved. This is also similar question. Here only oxygen atoms they are asked. Here number of carbon atoms, hydrogen atom, oxygen atoms have been asked. Mass was given 300 gram here also. And here also mass is given 3.4. So this 11 and 13 are similar. And volume is at HTP 1 mole equals to 22.4 liters. That formula we have to use. So not at all difficult question. I hope that you will do this homework correctly. Thank you for watching.